Test. Hello? Is it on? Can the people at the back hear me? Can you hear me now? Can you understand what I'm saying? Okay. Can the AV people dim the lights a little bit, please? I can't really see any of your faces. Okay. My name's Paul. The style of talks I like to do is a bit more engaging because every audience is different. Every community, every people are different levels, different styles and types of projects. So it really helps me in the beginning of the talk if, like when I'm asking questions, if you could just try and engage with me, it allows me to tailor the talk and to focus on points that are relevant and really spend less time talking about things you don't really care about as much. That makes sense? Oh, wait, where's the clicker? Hold on, one sec. We thought everything was going to go perfectly and we forgot the clicker. What? One sec, we're getting a clicker. I don't have, we could USB it. Here's a man, save the day. Cheers, Mike. Plug and play, right? It's Windows, it should work. Not. Ah, there we go, happy days. So, let's reset. I'm Paul, thanks for coming to this talk. I'm actually really humbled to be here. This is probably like the 4th or 5th time I've been to this conference, but I never actually spoke. I've given this talk about maybe like 7 or 8 different conferences over the past, years, and it changes every time. So trends and things are evolving, but fundamentally what I like to focus on is the things that don't change. The things that are fundamental, that there's all this noise in the world and all these new shiny things and all this new stuff, but it's the common things between the projects that I like to focus on, because that means if you learn it here today, it's not going to fizzle out and die out. It's going to be something you can take with you going forward into the future. Who has met me before or heard me speak? Just any hands? Okay, maybe that's good. So a lot of new faces, only probably about 20 or 30 people. By trade, I'm a principal engineer, principal architect, CTO, head of engineering, and things like that across multiple companies. In my career, I focus on software and DevOps and quality engineering more broadly. I kind of work on all of them at the same time or here and there. And then I've specialized specifically in CI/CD. Around about 8 or 9 years ago, I really started focusing specifically on CI/CD, especially in software companies when I was working there, because your software can be great. It can be fast. The front end can be great. The back end could be great. Whatever. You spend all that time in focus, but every single time you push code, every single time you want to deploy software or check software, and people within your organizations in the same team or amongst different teams, you all integrate and come together in CI/CD. It's the central point. And so if you have great software, but your CI pipeline is crap and it takes too long, then that's where I said, you know what, to the rest of the team, you build the software, I'll make this CI/CD stuff blazing fast so we all have a good experience and we're not sitting watching, getting paid money to sit and watch progress bars and things like that, right? There's nothing more infuriating than that. So for me, it's like, how can you take something that's got a long feedback cycle and you can get that into the shortest feedback cycle as possible? This is my 21st year, PHP. I feel really old. I was speaking to someone at the bar last night and they're like 22, 23 years. I'm like, well, okay, fair enough. I just want to say long live PHP. People keep saying it's going to die out, but they're wrong. We're still here. We've got PHP 7, we've got PHP 8, and ultimately we're starting to prepare for PHP 9. This obviously is not possible without open source contributors and maintainers and people from the PHP project, the internals team. They sacrifice and give up their time so that we all benefit from shiny stuff. So I just want to take a little moment of appreciation for the internals team. Just can we put our hands together for a sec, please? I just really want to appreciate them. Okay. At this conference, we've got Derek Rethens to give a talk. He's internals. We've also got George, who's also internal. He's at this conference. And we have Dan as well, Dan Aykroyd, who's not at the conference, but he was at the social last night. So they are around, and feel free to have a conversation with them because they're very friendly people. Anyway, this is myself. I do open source, things on historically, things on PHP, PHP Fig, Jenkins projects, Jenkins teams, Jenkins things. It's a part of the CD Foundation. I'm a conference organizer. I organise Scotland PHP. That's we just done our 5th year, just last year or so. Who's been to Scotland PHP? There we are, nobody. See you next year. By trade, I'm a speaker, trainer, consultant, and I focus on all these random different things. Basically, I just get my hands dirty and try and do my best to help people out. The CD Foundation, if you've not heard of it, the Linux Foundation, which is Linux. They have the CNCF, which is the Cloud Native Compute Foundation, and we have this sister organization called the CD Foundation, which is kind of a spin-off of things. You may not have heard of the CNCF, but you've heard of Kubernetes. Kubernetes lives in that project, amongst these other projects. And the CD Foundation has got things like Jenkins, Spinnaker, and these are 2 new. Jenkins X is basically the new cloud native, kind of shiny version of Jenkins that you can check out more about. I do specific talks on CD and continuous delivery, but this is a CI talk, so I'm going to breeze right past that, but I just want to make you aware that these things exist, and you can go on Google and check it out yourself. Despite all that things I did in my career, all the things I learned, I feel like this guy every day, basically. I really love this quote, because really, it's really true for me. Just the deeper I get, the more I realise how little I do actually know. All right? And ultimately, on a daily basis and a weekly basis, this is how I feel. All right? So it goes from 0 to hero real quick, and then back down again, and up and down. And I'm sure you can all relate to that, right? So that was the past. 2 years ago, 2.5 years ago, what happened? We had a pandemic. We have COVID, right? Some of us are working as employees. Some of us are working as contractors or consultants or something like that. And when COVID hit, what most companies did was they basically just chopped all the contractors and kind of nice to have people, and they just stuck to their guns and rode the storm because they have no idea what was coming. Me personally, I was working as a consultant, as a head of engineering for a company, and I lost my contract. They stuck with their pair team, so I was out of a job, and I'm freaking out. Please raise your hand for a sec if you lost your job, or you know someone who lost their job due to the COVID. Please, for a sec. Yeah, okay. So we're all affected, we all get hit. When that happened, I said, you know what? It'll be pretty easy for me to find a new job, but there's other people who are affected who are not in that situation. What's going to happen? So I said to myself, screw it. I'm going to start a new company. And my company is going to be focused on helping people find work, right? Because they're out of work and we need work. And just moreover, it's a very dying need to have companies that you can easily get into. And the path to get into find new work and to get jobs that you really love and want, the current path for that is to go to recruitment companies, right? They're salespeople, not technical companies, right? Or if you're working in a tech company and you have to interview people instead of building software, the people that you're interviewing, they're there because a recruiter sent over CVs of people doing keyword matching, fundamentally. And it's not a great experience on either side of the fence. So I said, you know what? I'm empowered to help myself and help others through the pandemic by getting them jobs and places to give them good opportunities. So the pivot of the company is basically, I said, you know what, I'm going to help people out, we're going to get good jobs, we're going to link people with good companies, but you can't just do it the same old way. I evaluated how hiring is currently done, and I always wanted in my career, working as an engineering manager and doing hiring stuff, I always wanted recruitment companies to be more like software engineering businesses that would perform substantial engineering screening on every single person up front before wasting a minute of my time or my team's time or my engineer's time. But it didn't really exist, so I had to go and build it. So for 2 years ago, we went full-time, and we've been really, really doubling down on everything. It's an end-to-end engineering-led solution, and we basically come and we take the pressure off of you guys. And then when you do have someone that you want to interview, they're going to smash the whole process, and they're going to love it, right? So basically, we're a sponsor of this conference, and you've got a leaflet in every single bag, all right? There's a QR code at the bottom, all right? Basically, if this is any, take a look at this, please. I appreciate it. What we want to do is basically start some kind of movement in the community where engineers are going to be talking to engineers, hired by engineers, and that's kind of what's keeping me busy, what I'm passionate about, what's driving me, what wakes me up every day, empower me to help people get into really good companies in the easiest and most seamless way possible, and that's what we're trying to develop. And so this is where I'm at, and if you talk to me, I'll probably just rant about this all night, so I'll just set expectations for that. Now we're moving swiftly onto the talk. The agenda is, a little bit of infrastructure. What I mean by that is like hardware, right? Because the pipelines are great, the code, the YAML files is all great, but you can't build your house on sand. And fundamentally, the speed and the execution, the capabilities of what you can achieve when building CI pipelines is ultimately fundamentally linked to the hardware that's sitting underneath it. And if you don't have a good grip or a good control over that, then the results above that are not going to be as good as you could. So we'll spend a little bit of infrastructure, which is just the base, and then we'll go straight into architecture, pipelines, and just mad stuff. This talk is a condensed version of the CI and CD training courses that my company does, right? This is only like a 45-minute talk. So what I've done is I've taken just bits of the whole course, between 1 and 5 day courses, and just trying to give as much different topics so it resonates with as much people as possible, depending on what you're interested in. All right. This is a dream, right? Everybody goes, I'm going to build a pipeline. It's going to be great. Yeah, that's good. But what happens? That's good for small projects that don't do much. But in reality, it looks like this, right? That's actually, although there's funny things in it, it's actually good. So you hear me talk about reflections, right? You want your pipelines to be a reflection of your organization and how you organically work as human beings to add value and automation, all right? But you can't do that if you've not got powerful tools and powerful control of what you're doing. What happens is your teams and your processes, if you're using primitive stuff that's kind of closed source or proprietary, like off-the-shelf things that you can't really control, your teams and the way you work and do stuff will end up working around the limitations of that software rather than having the software be a reflection of how you want to work, right? It's a trade-off. And that's also one of the trade-offs where you choose things like between Jenkins and say GitHub Actions. Well, GitHub Actions is actually probably the best one. That's a kind of proprietary general purpose solution. But there's other things that like before GitHub came, and I go into as a consultant and as a CI consultant, I was going into all different types of companies, and I see them trying to shift to like cloud things, but then like, oh, we can't do that in this cloud thing, we can't do that in this cloud thing, so we're going to have to adjust our processes, and ultimately I'm like, you're just dancing around the problem. Like, why don't you just figure out how to fix it in the first place, and then here we go. So we're going to do a case study. One of the case studies is the UK government, which my company has historically supported multiple different parts of the UK gov. And one of the pipelines I'm going to show you, when I went into the company, it took 1 hour and 20 minutes for each pipeline to run. That's per person, per push. So you're wasting money and wasting time. It's not very good. Hands up if you have worked in a company or currently work in a company that has a CI pipeline that's around 1 hour. The big ones. Okay, for your sins, all right? It's really not good. And even if it's like 30 minutes or 45 minutes, that's not good either, right? Because you're just sitting there. Company's wasting money, you're wasting time. Time is money, right? Let's build stuff. So that's an example of a Jenkins pipeline that I built. If you don't recognize this user interface, Jenkins has a user interface called Blue Ocean, which is the part of Jenkins things that I was helping contribute to building a little bit. Anyway, don't worry if you can't read it, because in the talk we're going to break it down. We're going to go through sections, all right? But ultimately this was something that takes 1 hour and a half, and this is the stuff that I built. It's all parallel things, right? Parallel. Basically, developers. So infrastructure, different tools have different things. Jenkins has got an EC2 plugin. You just give it your AWS creds and turn it on. Boom, works. Straight away, out of the box. Use spot instances. A spot instance from Amazon is basically an instance that you can pay per second or per minute for, and it's substantially cheaper than renting a virtual machine for 1 hour, right? Which is what they do. You let a dedicated machine or whatever. The price difference is like massive. So you're paying like literally cents, and you're only paying it for the seconds that you run your build. Whereas if you get a normal EC2 Amazon machine, you've got that machine until you basically turn it off and trash it. The idea of spot instances is like tiny temporary ephemeral machines that just on, off, and that's the kind of hardware you want with your builds, because it's cheap and fast. And if you want to do container magical workers for your builds, then you can turn on the Kubernetes plugin or whatever. Different tools have different things. A lot of the examples I'll give in this talk are Jenkins focused, because that's still the predominant largest tool in the world for CI, but a lot of this stuff is transferable to the tools that you prefer to use more conceptually. They look different, but the same concept can be achieved. Who here is currently using Jenkins still in their organizations? Yep, most people in the audience. Here's a tip. Jenkins, by default, runs in maximum durability mode, the slowest mode. but that's because if Jenkins has this very, very sophisticated failover and recovery process, like if some of the workers die or the master dies, the state between the workers and the master, like the master is the user interface, right? The thing that is the brain. It's atomic. I think atomic is that word. In databases, you've got something called atomic. Is that the right word? Where like it either works or doesn't work. It's like a transaction, and if it doesn't work, it will like fully like roll back, right? So databases have this thing called atomic. There's an acronym for it as well. Anyway, ACID. Thank you. ACID compliance, right? ACID is an acronym for the thing that means it will always be safe, and no matter what happens in the middle, we can recover from that. So by default, Jenkins is in that mode for max durability. So if you're going to go, one thing you can take away is go to your companies and go into the admin panel and change the drop-down to performance mode. Everything, the user interfaces, the screens, the buttons you click will just rock it, all right? That's the first tip. Next, you've got different sizes of workers you can control if you control your own hardware. Even on GitHub Actions and all these things, you can have two modes. You can say, hey, I don't want to care about the infrastructure, just let me use your infrastructure. But you can also say, hey, here's my AWS creds, make my stuff, and you can control the shapes and sizes of your machines. And that's fundamentally what we're going to talk about a little bit, is the shapes and sizes of your machines should reflect what you're trying to achieve. Rather than like one size fits all, because that general purpose isn't really how you're going to get good results, right? It's not. So the small worker, the big worker, right, which is like your main project, and it's a big project, it's a CI pipeline, just throw cores at it, right? And it's a spot instance, it's pennies, it's cheap, right? Humans cost a lot more than machines, so you can throw the money at this rather than waiting around inversely, right? And you can have a small worker for something like one of your smaller projects, a side project, if you're trying to do microservices, that kind of things, it's not as intensive, so you've got stuff there. Or if you want to do a CD pipeline just deploys things and waits for the cloud to do stuff. So obviously, you can, you don't need a lot of computationally intensive tasks because you're just waiting for things. So you can have big workers and small workers and medium-sized workers. And every one of these like workers, which is just a hardware configuration, you just give it a label. And then in your pipeline code, you just say, hey, this file, this repository, it uses this worker size. And then when you push your code, Jenkins just reads that and goes, boom, I'll spin you up on the fly, that worker. Or if it's already spun up, it will just allocate it, which is even faster. There's no need to spin up servers. This is examples where you've got big workers and small workers, right? Just to show you the difference. When you create a worker in Jenkins, you can see how many parallel executors there's going to be, all right? So this is different. This is your Git repo. This is just a Jenkins file. At the very top, you see it's the label of the machine I want, the label of the worker I want, and Jenkins will just give you it. The point here is when you create a worker in Jenkins, you can set something called the number of executors. And the number of executors is how many parallel builds, like when people are different in the organization are running builds at the same time, pushing code, how many of those pipelines can go onto that one machine at one time? Okay, so if you're doing something like small projects, you've got lots of little tiny projects or microservice things or a CD pipeline, the resources you're going to need for those is typically, you can say, oh, well, let's put 4, right? We can put 4, in parallel, there could be up to 4 builds at any time on this one machine. And nobody will really fight for resources because it's not that intense. Whereas, what my recommendation and my tip is, when you're doing a CI pipeline, and it's about speed and feedback cycle and getting that as quick as possible, set that number to 1. Which means there can only ever be 1 build running on that one machine at any time. That will give you the maximum hardware capabilities of that machine. So if you've got 24 cores, or you've even got 12 cores, your project that you're working on will have 100% hardware, and that's speed. And that's one of the tips on how you get it down. Controlling the number of executors if you own the hardware. That's basically what I was trying to say. I wasn't sure if I had that slide. Same thing, okay? Back to the big ass pipeline, all right? Next, for speed, mostly all CI providers let you do this in some different manners. 2 things. One, is in Jenkins, you can use the code or you can just use the UI. For example, shallow cloning is a Git. Hands up who knows what shallow clone means. Maybe about 10%. Okay. When you clone a repo, what does it do? It clones all the branches and all the history of those branches. But when you're in a CI box, you don't care about another branch. You care about your branch, and only your branch. And you also don't care about the history of your branch. The whole good thing about Git is you can roll back and you can look through commits as human beings. But CI is not a human being, it's a machine. So it doesn't care. You don't care, and the CI shouldn't care about what the history of the branch that you're pushed on is. You just care about the latest copy, right? And you don't care about other branches either. But so when you do that git clone command, it takes forever, right? And the longer your project exists for, and the larger your code base, the slower and slower it gets over time. So to detect yourself and to scale, you turn on shallow clone, and you give it a depth of 1, which means like basically I only care about the current version of that branch, and I don't care about anything else in the past. So before your tests even execute and you get that feedback cycle, the CI box has to clone your code, right? So I've seen projects in companies that takes 2 to 3 minutes to clone the repos sometimes before anything happens. They're just sitting there. So you can take that right down to like, what, a couple of seconds? Things like Jenkins and other tools, they actually keep a cache of your repo on their like private little temporary space, so it doesn't have to keep doing it as well, which is quite clever. So things like Jenkins do that as well. So so when you press push or you press a build button on the user interface, it's instantaneous because it doesn't have to fetch this stuff, right? This is an example of a Jenkins file. Anyone recognize this? Yep, this is it. You can write hundreds of lines of YAML, and that's cool. Jenkins is a new feature for YAML as well. You know, the YAML version of traditional, just to try and keep up, just to allow the community to kind of be in the same YAML mode. If they like YAML, you can build Jenkins pipelines using YAML. You just turn a plugin on, and it works. Just go on Google, check it out. But this is the Jenkins file. It's a DSL. So it's more verbose. Me personally, I hate YAML files. I want to have control. I want to be able to do stuff. Maybe put some if statements in there, right? Which is a reflection of the organization. If this is happening in the company, then do this. Otherwise, do that. So you can't do that really all that easily or cleanly in YAML files. So this is a very clean DSL, which is what's the type of machine that's going to pick up this build? Environment section, which is just environment variables, and you create them, and the stages of your pipeline. And that's the little green circles you see on that screenshot. That's all this is. And obviously, there's a parallel block, right? So it will just, you get parallel blocks, and that's how you start a parallel. It's super simple. People are a little bit scared. They're like, oh, Jenkins, blah, blah. I'm like, this is it. I'm not lying to you. It's legit. So when you have pipelines and you have all these steps, you see there's all these different circles, right? There's like 20, 30, 40 steps. When you are in development mode and you're building features, let's say we've got at the top, if you can't, hopefully everyone, can the people at the back read that, or do I need to zoom in? Well, thumbs up. Give me something. Thumbs up? Ish, right, okay. Docker build, unit tests, and test suites, which is like the big ass test suites. These are ultimately, if you have changed code that lives in the back end part of the project, and you only want to run the unit tests, you don't want to wait for the end-to-end test to run as well to get a green build to say, hey, I can merge my code, because you didn't change the user interface. You didn't change anything, so why, when you're in that development feedback cycle, why wait for other things that you don't care about because you didn't change that part of the system? It's not going to fail, and if it did, it ain't your problem because you didn't change that, right? It's like something else happened. So these are switches, and this is a very, very technique I use. At the very top of your Docker file, it's global variables, right? You just create variables, and all the steps on the master are all on. But if you don't care about, there's bhat at the bottom, right? BDD tests, that could be over an API or a user interface, for example, right? What if I didn't change the user interface or I didn't change the API? I don't want to get that, I don't want to wait for that to run because I want to do other things with my time. So you just change that true to a false in your repo and hit push, boom, it won't run. Not for master, because you want master to run everything, but these are techniques that you can apply. In Jenkins, it's super straightforward. In other pipelines and other YAML systems and stuff, it's not so easy to do this stuff because you don't have control. You're giving control to another company, right? So step one, on-off switches. Turn them off, get your feedback cycle, get that all moving, and then turn it on when you're ready to get to the end of your branch, right? So that's first. That's another tip. In Jenkins, there's a when condition. If you use Laravel framework, they do this kind of stuff too, quite similar. So this is just one of the stages, and there's a when. So it's a Boolean expression, and it just says when it's a true. So at the very top, I can just go in and go false, 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 turn all that off, push, great, then turn it all back on when I'm done. Make sense? Switches. This is defensive programming. This means that in my when expression, I can say, give me the branch name, and if it's master, it's going to go cool, and it's going to run it every single time. This is a fail-safe. This stops people from turning off the steps in their development branch, and then no one notices, and you merge the code, and then master branch is building, and it doesn't run things that is fundamental to the business. So it's a fail-safe. It's one of the examples I use in companies. When I put this, I go, right, great, you can turn it all off, but if it's on master, we're not even going to consider that. It's always on, because it will always hit that. So it's an OR condition. Make sense? This is onto the init section of your pipelines. Okay. Again, it's parallel. We're only going to talk about the clean env part because this is important. Clean env. This is what clean env looks like. Hopefully, you can all read that. And there's some logic and some good kind of tried and tested methodologies behind this. First of all, rather than doing a git clone, which takes time, let me rephrase that. Sometimes, for example, if you own your own hardware, right, and you have a box that's been spun up for build number 1, build number 2, that machine has a shutdown period, like on AWS and Jenkins, you set the configuration like after 20 minutes of nobody using this box, turn it off and it will terminate, right? That means that the machine is already booted and then subsequent builds can just keep using the same machine over and over and over, or machines, because that's good, that's what we want. One of the good things, the way specifically Jenkins works, is it will stash your repos on the box somewhere. And when you need your repo, it just copies it in, yeah? And then does the pull for the branch you need, which is very, very fast. And so that's what the first point is. The repo can still be on the machine that you were using last time, so you get even more instantaneous kickoffs for your builds. The second part is the clean. What that means is, I'm not going to tell you what that is, because there's a bit at the end of the talk, and it's going to come full circle, all right? Anyway, the point is, always clean your branch, the state of the machine that you're running it on, clean it at the beginning, not at the end. If you clean the machine at the end, of, like, you do your repo, and you clean down the hard disk state, it means that if there's an error on your branch, on your pipeline, and you want to go onto that box and debug that, you can't, because the pipeline wipes the code, doesn't it? It's like, hey, here's a problem, gone. So you don't. You always leave the CI box in the state that it failed at. And therefore, then subsequently, if you do a push on the same branch again, it will clean it. Does that make sense? When flipping the logic, and so it's a debugging thing. Next is about linting. These are things you can lint. Linting is probably the most undervalued thing that you have that people don't spend enough time on, in my opinion, which is these are things you can lint. And if you can't read it, obviously the live streams here, things like that. You can lint Docker files. So before you even try and do a Docker build, it's like, oh, you forgot a backslash or a semicolon or something ridiculous, right? And you have to wait all that time to get to that feedback. You can lint all your Docker files and all your projects immediately. You can use PHP, the PHP binary has a -L flag for lint, but it only receives one file at a time. So there's a plugin that parallelizes that thing, so you can parallel lint your PHP files. Nothing worse than getting to a Docker build, and then your Docker build's ready, and then you run your unit or integration test to realize that you've got a syntax error in your PHP file, right? So linting with PHP native is slow, so parallelize it, yeah? You can even parallelize the parallelize. That makes sense? Because if you've got like 2,000 files in your repo, and you're waiting you run one command, which is the parallel lint, it can only do so many things at one time. So if you segment your project into like folders and run the parallelizer guy on, and in CI it's got separate steps, then you've actually taken that time and you've, so it's parallelize to parallelize. It's hard to, it's easier to show people hands-on, but I hope that made sense. Anyway, you got Docker compose files and bash scripts, number one, that's why it's number one. It's hard to know what's going on in a bash script until it runs, but there's things that can tip you in advance. So, linting, because the Docker part takes time, right? The Docker build part will take time, usually a couple of minutes, right? 2-3 minutes. Any more than that, something's not quite right. When you're doing your Docker build, this is where you want to throw your hardware at it. Also, things like composer install and npm install, that's where the CPU will get hammered, right? And that's time. So, when it comes to Docker build, that's where you really want hardware, because you can go from 3 or 4 minutes down to 20 seconds, right? 30 seconds, and that adds up, right? For you personally, when you're doing your work, and for everybody in the project. You can't deliver it in time because your CI is slow. And yeah, AWS bought instances for the hardware. That was a lot of hardware. It's cheap, trust. Anyway, this is, when you're doing a Docker build, right, the first section, which is just do a Docker build, the concept I want to teach you here is work ahead of yourself. Now, it's like techie people, we like being quite like, okay, apples go here, bananas go here, oranges go here. So for example, all your Docker build steps are here, and all your unit test steps are here, and all your integration steps are here, right? And I used to think like that too. And then I realized there's a time penalty for like the preparation time before it can run things. Like, for example, if your integration tests are running and you need MySQL or Redis and their Docker images, it's going to have to pull them down on the web first before it can actually, and then spin them up, and before it can actually run your tests, because your tests need a database, right? So when you're doing the Docker build, after Docker, after the build, you've got your unit tests, and after your unit tests, you've got your integration tests, okay? So my point here is, for the next phase in my pipeline, I'm going to need these Docker images, for example. So do the stuff, the step before you need it. And I guess that's the phrase, right? So because the Docker build, it will take time. It may take 3 minutes. So you've got 3 minutes to do stuff on that machine before you need it. And when you get to that step, then it runs and boom, there's no boot time. And that's another technique how you can get your build times down. When you're building pipelines, don't do this. Okay. This is in a Jenkins file. It could be in your GitHub YAML file. This is a human thing. It's nothing to do with the tech. As humans, we just cut corners and we're lazy, or we just don't. Some people just don't give a shit, right? So if this fails on the CI, how do you go into your local machine and rerun that? Or even on the CI box and run it? You can't, because like it's just mad gobbledygook stuff. It's not repeatable. You can't have idempotent steps in your pipelines because it's all locked inside a vendor's file. And it's just spaghetti mess. So don't do this, do this. Bash literally saves the day, which is unlikely because you're like, ugh, bash, it's a bit nasty. But ultimately, the true power of building a pipeline is, in the software, the CI software, is to not actually build your pipeline in the CI software. Because you can't switch from Jenkins to GitHub, or from X to Y, or Z to Y, because all your code's invested in some kind of proprietary YAML syntaxy thing, right? It's no longer your code. You're at the mercy of a CI tool. So get out of there. And by design, so this is kind of like the second section of the talk now, where we're going to pipeline architecture. We design our software, and we architect our software, but we don't design and architect our pipelines. And that's where, years ago I started doing this, and that's where the results started showing. One of the benefits of doing this, not just that you could get out of that vendor file, but you can run this on the CI box. If you SSH onto the CI box, you can just run that. So I keep pointing. It's because the screen's here, right? I keep pointing at that, right? So if you wonder what I'm pointing at the floor, right? You can just run this manually on the CI box yourself and repeat what the Jenkins runner was doing, but you've got a state that's like very particular. You want to debug it. You don't want anyone to touch this machine. It's like your machine. You're debugging it, and you can just copy. You can just paste that. Boom. Like for like. So that's good. That's how you find bugs quick and easy. The added extra, which is you can run this command on your local machine. You are the CI box at this stage, because all you need is a Linux box with a shell. And you can run that. For me personally, when I do this as a job, I build the CI pipeline on my local machine. I don't use the CI machine at all. When I'm happy with it's functional and working on my local machine, then I'll run it on CI, right? And I'll pick up maybe some edge cases I didn't think of. But the only way you can do that is if you get pure control away from the CI software. We do that with frameworks, right? Software talks, they go, frameworks, build framework agnostic code outside of the frameworks so that you can, move it between projects, it lives forever, you can test it in isolation. Good, but nobody really talks about it on CI. So this is my way of saying, same principles, they're important principles, and when it comes to CI, this is what I recommend. This is my pipeline architecture, right? In the CI/CD folder in your project, I've got steps and test scripts, okay? Docker is involved here, so I'm trying to explain this. For me, this is a bit of a game changer. That really helped me out. If you look at the code, it's going to run a bash file on the host, which is the CI box or your local. And it's going to be in the steps folder because Jenkins calls it steps. So it's like step, 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 all of the little green circles. So these things here on the right are actually commands that will run on the host. And the ones that are at the second folder are things that are going to run inside your Docker container, right? Like PHP unit run or bhat go, right? So this is an example of something which is the run PHP in the steps folder, right? This is CI, this is the whole task end to end. There could be multiple things, right? But it's one file. That's good. When you need to debug it, you can run one file and it'll do all the kind of bits and bobs. In Bash, we have settings that we apply. E is for error, which means it won't run every command in the whole file, and then error. It will stop in that Bash file at that line where it failed, where it got an exit code that's not 0, right? It's the way Linux works. So -E, so I always do -E, which means that if the first thing fails, don't try and do more things, because that doesn't make sense, just like how PHP works. So the same applies, -E. -U means user variables, which means if you refer to a variable in this script that doesn't exist, it will also die. By default in Bash, it's kind of like falsy and loosely typed. So if you try to refer to something that doesn't really exist, it can kind of silently just become like an empty string because it doesn't exist, and that's not what you wanted because it's fundamentally wrong. So -U means it will also fail when the variable that you're referencing doesn't exist. And X is awesome. Debug mode. When you run a Bash script with -X, this command here has variables in it, right? Strings. It will actually debug output to you what the real command that's getting run as, not what you think it's going to be because there's variables involved. So when you're looking at the output log of your CI run, right, and you've got an error, it will show you the actual real command that it ran in addition to the original thing. So I hope, did that make sense? What I'm trying to explain with the X debug mode. You don't have to have debug mode all the time, but if you turn it on, you're going to see everything on a machine that you're not on, and it's really insightful. It really helps with debugging, because debugging is the hardest part of CI, in my opinion. So this is on the host, and it's a Docker thing, and you have your image. Phoenix is the name of your project. So you've done a Docker build, and you want to run stuff. The image of your Docker image is the same. It's your code base over and over, but every time you run that, you can override the entry point, which is the script that will initially run, and the container will die when that script is finished. So you can have, 4 different files, or 4 separate files with your different things. It's the same Docker image, same code, exact same environment that's like production, and every time you run that container, it's going to have a different entry point, right? Different script that gets executed. Rather than fpm, nginx, that's the default entry point, it's going to be what you want, which is your test script file, which is the file that is part of your project, and it's inside the container, and it looks like this. Recognize that? Standard PHP command, run PHP unit, run PHP stan, right? So ultimately, the concept is you've got files that run on the host, you've got Bash files that run on the host, and you've got Bash files that run inside your container. The ones on the outside is to say do Docker run things, and inside of that, run the entry point, and then the guy inside will do this stuff. Again, it's all simple files that, there could be like, if you want to run PHP stan or do static analysis, there could be like 5 or 6 commands. So you don't want to expose that one raw command up to the CI level, because then you have to like manually run one command and manually run another to try and debug it. So you just run one script, right? The awesome thing about this is the speed that you can develop the scripts and test it and changes, because I can just shell into the Docker container, right? And I can just run this run PHP stan. I'm in the container, and I'll just run that command over and over and over. Just put it up and enter, and I'm changing the code up and enter because I only have to run one thing, and I'm in the container. So whatever the CI ran, the CI said Docker run something inside, then I can just do what CI, I am CI, right? Did that make sense? Okay. I tried to explain this quite a few different people over the years, and at different times it kind of hits or doesn't. Okay, so outside, inside, that's your architecture, and you are now the CI. Your local machine is the CI box, and that's how you can achieve it. Building things in parallel. So more Docker stuff. Your Docker file should ideally not look like the thing I said. Don't make it look like that on your CI. please don't make your Docker files look just like random bash stuff, right? Most projects look like that because it's easy and convenient. But see, when you want to do an SSH you want to shell into that container, that running container, and run and debug and do stuff or develop the code, you can't because it's in a Docker file. And you have to copy it out the Docker file and paste it into your shell. And often there's variables there and it just doesn't work. So how can you build stuff and debug stuff that when the Docker build does run, it's going to be exact? And the way for that is to, again, similar technique, get it out. Now you've got a shell, and that's all you need. All right? This one's awesome. PHP health check actually exists. FPM health check exposes metrics about the workers and the runners. With things like New Relic and all that, they all look about, like Kubernetes monitoring, they all look at how many, like, what's the traffic, right? And how many containers do you have in auto-scaling? But they don't tell you what your PHP runtime looks like. Not really, not that easily. FPM is a fast CGI process manager, and it's workers. It's basically, Node.js is almost conceptually the same idea, right? It's just workers, and the workers run, and you can scale the workers up and scale the workers down, and that's what FPM does. So when you're in production, and you want to expose those metrics out to the cloud so you can see the actual internals of the PHP FPM, there's a package called FPM health check. Just go and Google it, and then you can install it. And then, boom, the logs go out, and it gets sucked in, and you can see exactly what's going on. So that's another tip that helps. Here's another tip. PHP command, me personally, I use --r, which is the extensions that you've got on your, the extensions that you install, right? Blackfire, pcov, xdebug, and all the other, any extension, right? MySQL, they all have --ri and --re, right? --ri is a kind of more in-depth version of all the any settings of your extensions, all right? So it's kind of like a PHP info page, but it's on the command line, and it's a lot easier. Yes, PHP-i does exist, and it spits everything out, but in this case, you specify the extension you care about, and you get the structured list. And then I can just say, pipe that to grep, make sure pcov support is there, and then make sure I can then grep that again for the word disabled. Because in this case, in production, I do not want pcov, which is a coverage thing for unit testing, I do not want that in production. But I do want it installed in Docker image, so I can use it. So this is like an idempotent line, where it says, basically this will fail, right? If it's enabled by default, like you don't want black things like xdebug in production, right? I mean, most of the time you don't, right? Because it's so slow, it will intercept your calls and it will make your software slower. So this is like a fail-safe to say, I want this extension, but it should always be off. So it's in a little tip, it's like Boolean, and you'll catch things like this. You can get a little bit creative, but then the tip is -ri, right? Make sure, a lot of people install things like extensions, or they do config files. They copy any files across into their containers for settings, whether it's just CI settings or production settings. And sometimes you can accidentally do things that you don't expect. So this is your way to ensure that the previous line didn't, or a human being did not make a mistake, because fail safe, yeah? So that's a tip. Because pcov is off by default, which is the coverage generator, what that means is at command line time, so this is the run unit test.sh, right? That's inside the container. This is this file. So I can say php -d, D stands for directive. We borrowed that from Javaland, and you can just enable and disable any system level settings on the command line on a per run basis, okay, per command. So in this case, we're saying PHP, I want pcov enabled now 1, but that's because I only want it enabled for my unit test, and outside of that, it will not be on ever, right? So that's the point, right? Also, if you're on CI and you're running this, you want to set the memory limit to -1. Who knows what -1 is? Yeah, -1 means don't have a limit of memory that PHP runtime will allocate, or the Zend MM under the hood, it's the memory manager. It will not try to do memory management things and be constrained. It will just go blaze it. So that's how you get your unit test suites to be as fast as possible, by giving them the maximum amount of RAM on that machine. And if you've only got one build on that one box, then in theory you've got 32 cores of RAM, 32 gig of RAM, and you can go nuts. Next, secure Docker files. Docker build kit is the new shiny version of Docker, which is was historically the experimental version, which is now the main version. You're probably using build kit now and you don't even realize it. It's just like Docker v2.0, right? It's just how they progressively bring features into the ecosystem without breaking or changing the original thing, right? So it's an environment variable. You just set it on and it'll do cool stuff. And there's new things you can do. There's so much. You can go on the web and just type in build kit new build kit features for Docker, and it'll show you this awesome stuff that's been added since the initial kind of conception of Docker. So there's secrets, which is like SSH credentials, but they don't exist inside your Docker file. So you don't have to copy your sensitive credentials in there to do sensitive stuff. I'll give you an example of something that's sensitive. You've got packages.org and all your packages, but you've got your own private repos, right? You've got your components and your libraries that you share, and those are your own private Git repos, right? So you need credentials to talk to your private GitHub or Bitbucket repos. So you don't want stuff in your container. You don't want to copy stuff in because Docker is built in layers. So even if you wipe it at a later layer, it's still going to be there, and people can look at your image and they can steal your stuff out of it, right? So you don't want to get hacked. So you just refer to things. In this case, the auth.json is actually a composer auth.json, because in your composer file you've got the path to your remote Git repos that you're filling in, for example. So anyway, point is, there's build kit. It's got all these shiny things, and you can do shiny things with it and keep yourself secure. All right. So, and not just security stuff. There's lots of other cool shiny things you want to check out. All right. Next is the unit test section. Unit tests, they're just unit tests. We have multiple projects in the one repo, but sometimes your unit tests are you've got so many tests, you might want to break your whole unit test suite down into little sections as well. But the point here is prepare for your integration tests. So while you run your unit tests, prepare for your integration test phase. To reiterate, for example, pull Docker files down that you're going to need, Docker images down for like MySQL and Redis that you're going to need for the integration part. You don't need integration, you don't need databases for unit tests, right? But you do need them for integration. So it might take maybe 45 seconds for your unit test suite to run. So you could fill that with random stuff. And at the bottom here it says integration prep, which is my thing, right, that I needed. Integration tests are Docker Compose, right? This is Docker Compose. The top is the image of your project that you built and you refer to it. And these are all the extra things you might need, right? Kind of emulation things you need in production. You've probably seen this before. It's literally, but the key thing here is, it says, at the top it says API tests. So this is not your normal Docker Compose YAML file that exists on your project locally. This is a Docker Compose.ci.yaml file. So it's a specific YAML file that's only CI is going to use, which is specific and different to your local Docker Compose file. Laravel's got this thing called, keeps so many names, forget. Is it Sail? Is that right? Laravel Sail is just a wrapper around this, right? It's just Docker Compose, but it's got like convenience things to make it easier for beginners and stuff. So, anyway, it's API tests is the name of the service. That's usually like app, right? Your app, but in this case you have a key. And what that means is inside this you can set the entry point. Similar to what you've seen before when we said Docker run, -- entry point. It's a bit long-winded, right? What you want is you want an entry here in your YAML file for all the different test suites that you want to run, that you can run. Unit tests, integration tests, suite 1, suite 2, bhat, user interface, whatever. If you have an entry here, what it means is that when you run Docker Compose commands, this is the very end. At the very end, it says, right, that's the service that you're launching. You're not launching MySQL or app. You're saying, I want you to spin up a container that matches the definition of this guy. And the definition of this guy is inside the container, your test scripts, right? Which is going to be like run PHP unit or run whatever, right? So that's one part of it, which is your YAML file, which is really clean. But the second part, this is how you parallelize stuff. Docker Compose has -p. It stands for project, okay? And at the top of the slide, it says it isolates Docker networks and containers with -p. It kind of namespaces them, okay? If you do Docker Compose up, right, and you've got a MySQL there, and you try on the same, in a parallel step on Jenkins or whatever, and you do something else up, it's just going to go, MySQL's already up, and it's going to be the same thing, because by default, Docker Compose project is called default. Don't know if you've noticed, if you do Docker Compose or Docker Compose list and you see all your containers, they've got this default underscore prefix, and you're like, what the hell's that, right? You don't really pay attention to it. What this means is I can take the same image, my same application, and I can use that in different contexts because the entry point each time is different, but the code is the same. It's production. So -p is the API test project, and this one's the UI test project. Same code base, same YAML file, but the service at the very end is different each time. And if the service name at the end is different, it means that the entry point will trigger. The point is, now, the different network in the containers, you'll have different MySQLs, right? The clones, so your MySQL and your Redis and your Rabbit, it's going to have a copy of them. And they're going to be contextually isolated, and you have a different script that executes on each one. Make sense? And that's how you can parallelize the hell out of anything you want when you do it with -p. All right? This is another tip. If you've got large code bases, especially join a project or there's legacy stuff or there's nasty things, right? And it's going to take you months and months, maybe years to take this nasty test suites that are messed up over years and be able to run them in parallel. I'll give you an example. If you run integration tests and you try to turn on PHP Unit's parallel feature, or you're just trying to run tests in parallel, even if you use an interface test, they're all hitting the same database, right? So like this test creates records in a database, and then the other test goes, oh, what the hell's that? Because some guy broke it. So by default, we run tests in sequential, right? Slow, sequential, 1, 2, 3. But that's okay because it means the first guy won't do stuff with the second guy's data because the database state is important. And so what you can do is you can isolate the same test suite and the same test into sections, right? And then you can do -- test suite on the command line for PHP Unit, and it will run section A, B, and C. So this is where the speed decreases the most of all the tips I've given today. It's because there's the slowest part, the slowest test, functional and user interface tests. So if you've got a user interface test suite that takes 20 minutes, and you chop that into 4 pieces, it's going to run 5 minutes, right? I don't know if I got the math wrong there on stage, but whatever. Anyway, literally, that's what we did for a customer. We just isolated the tests that were conflicting and could not run in parallel. And now we run them in parallel, but the point is they've got separate databases because we used -p, 7db. So you maybe for master branch, you want to run them all, just sequentially. It's to me, feel more comfortable. But for your feature branches and all that stuff, you can just break them down. I call this test segmentation. Maybe not the best name for it, but it's a word I use to describe to people how to really break something apart, right? PHP Unit has a Parallels plugin. So just turn it on. And then it just runs in parallel. It uses workers under the hood. And those workers are tied to the cores on your machine. So you just say, go to the cores. Laravel just added a little -- parallel flag to their test runner thing. And it's just a proxy for Paratest. So Paratest is the plugin for PHP Unit. So if you've got unit tests, integration tests, whatever you need, just turn it on. Boom. You start doing workload across cores and parallel tests. But if you start doing parallel tests and it starts going mental because the database is in a weird state, then you can segment it. Solved. It's not clean, but it works. That gives you time to, in isolation, try to fix the tests, right? Actually fix the test, but in small, manageable chunks, and not trying to big bang the whole test suite. Next, post steps. So in Jenkins and all the pipelines systems, you can do pre and post. So after the pipeline is complete, do stuff. This is common for things like Slack, Notify, right? Build is green and it posts into your Slack or something like that, right? So that's one example, something you want to do at the end. But this is important for speed. What's the next slide? Okay. At the beginning, when I showed you about cloning the repo, like when the CI software clones the repo, just to read your YAML file to then know what to do, we're talking about enabling shallow cloning, right? But there was also on that slide a thing for tags, right? When you clone code on CI, always do -- no tags on the clone, right? Because you don't need tags to clone your code, your feature branch, right? Tags are one of the slowest parts of all of Git. I don't know why, but it just does. And every time you make a tag, because you're doing a release, the more tags you've got, the slower the clone is, because by default, git clone builds in tags. So at that earlier stage, I would say always do -- no tags on your command, or just press a feature, right? And on GitHub Actions, there's a YAML thing that says tags false. Boom. That will speed up your clone. But the issue is, if you get to the end of your pipeline and you're on master branch and you want to automatically create a release, and you type in git tag and you give it like a v1.1, 1.2, it's like, sorry, I don't have any tags. I don't know what you're talking about, right? Or you need the previous tags to know what the bump should be for the semantic versioning. So you only really need tags if you're at the end of the pipeline and typically if you're on master, because you don't want to create tags on a feature branch. So the example is, if it's master, then get me the SSH, become an agent, and do the fast git clone, and there you fetch your tags. So it's really, really slow. And if you don't realize it, like try and speed up, do it yourself, clone your repo, and type -- no tags, and then clone your repo without that, and you'll see if you're doing tags in your project. I honestly have so many companies I went into, and I'm just watching the git clone, and it's just like tag, 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 and I'm like, I don't even care about your tags. So turn it off, but then turn it on. This is how you turn it on the fly when you need it. And that's that. Builds. I was talking about earlier on about cleaning the disk. This is about debugging, right? Like, there's a problem, right? What do? You need to figure it out. Don't wipe the disk during your build. Clean it at the start, which is this guy, right? So now you can go into the box and actually see, well, what does the hard drive look like? What do the files look like? Next part about debugging, which is probably the hardest part of debugging, is when you've got user interface tests, because they're the nightmare, right? There's no longer code running, you've got a browser running with JavaScript and all sorts of mental things, right? And trying to figure that out on a local machine by watching the CI, watching the runner do the clicking or whatnot, is hard enough. But when the user interface tests are not even on your computer and they're on a remote computer that's headless with no browser, how are you going to do that? Well, the good news is, right out of the box, you can... Who's here using Selenium to do browser tests here? Okay. If you're doing browser tests and you're not using Selenium, what are you using? Louder. Cypress. So Cypress, Selenium, etc. When you're on a CI box and it's headless and it's running, you want to, and it keeps failing, and you're like, I don't know why. They're Docker-based, right? So you have a YAML file for your Selenium browser, right? And it has browsers. There's a debug mode on them, and you can turn them on. And when you turn on the debug mode, what it does is it actually installs a VNC client onto that container run with a port, So on that host, if you let that port open, on your local computer, you can watch CI in the browser run. And you can just watch it, and you can see what it does. Even better, when you're looking at these tools in debug mode, there's a read and a write mode. So by default, it's read mode, where you can't touch the browser, but you're watching a browser of a remote machine and CI running your tests. When you go into write mode, it's even better, because you can put a sleep command in your test, your UI test, before it fails, and then you can just open up, like if it's Firefox, you can open up, or Chrome, debug toolbar, and you can just look at the DOM. You'd be like, oh, that element doesn't have that class on it that I thought I had on, so that's why it can't find it, and that's why the test fails. It's really, really, really hard to find UI bugs if you can't see the UI. So this is how you do it. All right, and just Google for Selenium Docker debug mode VNC, and you just remote desktop into that runner container. Does that make sense? Passwords. Hope you can read this. This is a block of code. This is using a tool called Gatling, which is a Scala tool for just load and stress testing. I use this for the UK Gov to do all the stress testing when it's master and it's on a special environment. It says if the target is in pre-prod, right? It's just a function that returns true or false, because I know the branch I'm on, I know where they want to deploy it. This is a CD thing, not really a CI, but it's similar. You want to have a pipeline that runs stress tests against a target environment, or security tests, or some kind of thing. It's not part of your core pipeline, your core CI pipeline, but when you take your code and deploy it, like staging or something like that, you want to do extra stuff to that. And so you know where you're going. So anyway, it says if it's pre-production, otherwise do something else. Now, the point here is with credentials. So GitHub Actions is the same thing. You just use the secret manager. That's the point, right? If this is a Gatling tool that runs against a user interface, it's clicking buttons, but it has to log in first. So how are you going to log in to a production-like system with production credentials to do load testing that's kind of production-like user behavior? how are you going to know where the passwords are? You've got to store it in a secret manager. And that's what my point is. Store your passwords in secret managers. And then they become environment variables within your code. And so, simple, you just read from the env. And so in Jenkins, you say, what's credentials? And then it's pre-prod login cred ID, because that's just a variable at the top. That's the string for it. Every time you create a password entry in a password safe, you give it a key, right? And so that's the key. But the environment variables that it will create when it brings me to a shell to run Gatling sh, it will create Gatling login user and Gatling login password, which is just bash variables, right? So you can take this out of context and put it into a CI pipeline, whatever you want. My point is passwords, environment variables, and you're good. And that kind of protects you, because you try and do this stuff. I've seen a lot of mental things. People putting default passwords in repos. The problem with Git is once it's in the history and you push it, you can't take it out. You can, but you're rewriting history at that point, and good luck. So once it's in, so just don't put it in, and then you won't get hacked. Yeah. Who knows what this is? Shout out. Go on, hit me. What is it? What's that? Starship Troopers. Exactly. Love it. Okay. Anyway.
Paul, just to let you know, we're running over a tad, so you want to wrap up in about 5 minutes, if that's all right.
That's fine. Cool. That's the end of the talk. Not yet, but if you'd like to know more, my company, we do CI, CD, courses for your teams, come into companies, and myself, my consultants, we go into companies for a X period of time, and we come and help you out. All right, fix your stuff for you. So if you want to know more, or you want to fix things in your businesses, and you want to get blazing fast pipelines, or just fix problems, then give us a shout. Thank you, and that's me. Done.
Thank you, Paul. I do want to see if anyone has a really burning question, raise your hand really fast. We'll get one question in. If not, no questions. All right, thank you, Paul.